Let's say you wake up one morning and you look at your window and you see this weird sign. And there's I equals 1 and it goes to 10 and it says I. And you have no idea what this means. Do not worry, I'm here to decipher it. What all this means, let's start with the sigma sign. This is the sigma sign, specifically the uppercase sigma sign. It's a Greek letter, and all it's telling you is to add things up or sum them up. What I mean, obviously sum is with the plus sign. All you're doing is you're plugging in I equals to 1 into this expression. So when I is equal to 1, I is 1, and then you're going to go on. You're only going to look at the integer values, so you're only going to do 1, 2, 3, and so on, up to this value, which in this case is 10. So all you're doing, you plug I equals to 1 into it, so you have 1, plus I equals to 2 into it, so you have 2, plus I equals to 3 into it, you get 3, and all the way to 10, plus 8, plus 9, plus 10. And this is what this is summarizing. This is what it's talking about. And you may be asking, what's the point of writing it like this? Why can't we write it 1 plus 2 plus 3 plus all the way to 10? Because, one, writing this way is more compact. Let's say you want to write 1 plus 2 plus 3 plus all the way to 10,000. All the way to 10,000. It is much clearer to most mathematicians if you're summing it up from I equals to 1 to 10,000 of all the i's. Also, writing this way allows you to specify some patterns. In, let's say you're doing 2 plus 5 plus 5 plus 10 plus 17 plus so on. If you just write it like this, it may be hard to realize what's going on. But if you write it as sum from I equals to 1 to, let's say, infinity of I squared plus 1, then it's much easier to see what's going on. What I mean, when I is 1, you have 1 squared plus 1. So you have 2. When I is 2, you have 2 squared plus 1. So you have 5. When I is 3, you have 3 squared plus 1. You have 10 and so on. And obviously you're adding them up because you have the sigma sign. So this thing also allows you to specify what each of the term is in a clearer way. So that's why we use the summation sign, and we are going to use it a lot to define what definite integral is in the later videos. Now, just since I have it, I want to show you an easy way of evaluating 1 plus 2 plus 3 plus all the way to 10. You may already know it, but I'll show you. Let's look at the first term and the last term. What's 1 plus 10? Well, 1 plus 10 is 11. Let's look at this one and this one. Second ones from the top and second one from the bottom. 2 plus 9 also gets you 11. How about 3 plus 8? 3 plus 8 also gets you 11. So, and how many 11s do you have? You have 5 11s because you have 10 numbers and you're putting 2 of them. 2 of them gets 11. So you have 5 pairs that's going to get 11. So the sum is going to be 11 times 5 or 55. I encourage you to try the same method to prove that 1 plus 2 plus all the way to 100 gets you 50-50. But that's not the point of this video. Now let's get more into summation. Actually, before I get too in depth, I want to make sure I specify the I equals to 1. This is the not initial, lower bound, I meant to say. Not initial, I guess you can think of it as being initial starting point, but it is called the lower bound for the summation. And this 10 is called the upper bound of the summation. Now, let's try to decipher some interesting summation. Let's say you have sum from I equals to 1 to infinity of 1 over 2 to the I. How would you expand this? All you're doing is just plugging I equals to 1 into it. So you have 1 over 2 plus I equals to 2 into it. 1 over 2 squared plus 1 over 2 cubed plus all the way till infinity. You're doing this infinitely many times. So you get 1 over 2 plus 1 over 2 squared is 4 plus 1 over 2 cubed is 8, and so on. And you can use a geometric series to prove that this is equal to 1. I'm not going to do it here, but you can use a over 1 minus r. That's the expression for the infinite geometric series with absolute value of r less than 1, which is the case, but you don't have to worry about that. We are going to look into geometric series later when we get to the final phase of calculus BC. Now let's say we have something expanded and we want to put it in an expanded notation, 1 over 1 plus 1 over 2 squared. Let's say that's 1 squared 2, 1 over 3 squared plus 1 over 4 squared, and you're doing this infinite times. What is this same as? Well, let's start by writing the summation, and I equals, and you're going to have some expression of I. Obviously, I is starting at 1 and it is going on infinitely, so we're going to start with I equals to 1, go up to infinity, and we are doing 1 over I squared, so that's going to be the answer. And the famous mathematician Euler has proved that this sum actually equals to pi squared over 6, which is fascinating.